It's great to be here. My name is Jason, the co-founder for Solayer. So just a little bit background about myself. So before this, I started MPC Vault, which is a multi-sig wallet used by a lot of businesses today, facilitating transactions about like $6 to $10 billion every week. And through that experience, I've come into contact with many different chains and different semantics of constructing transactions, and also got to know a lot more about in-depth as a developer for each and every chain that we support, like Aptos, Sway, Solana, everything included, about the UI and the UX. So a lot of the work that we're doing here is based on our team's shared previous experiences at different places. Another thing I did before this was accelerating large language model training through data pipelining, model pipelining with a better scheduling algorithm. It's called TikTok scheduling algorithm. The reason why I'm mentioning is because we're not trying to hop onto the AI trend or AI agent trend, but we do find many of the AI training techniques and mechanisms and the equipments protocols used very handy when you are trying to build a high performance chain, because the optimization goal is very similar, just lower latency and higher throughput across different nodes and for communication. We have other team members from Sushi, AWS, I don't know who changed that letter, and Microsoft, and a couple of other companies as well. They're all very experienced infra engineers. We don't necessarily hire just from Web3. We hire from Web2 who are very much deep into the infra sort of space. We also just want to announce the recent acquisition for Fastland. And then through this acquisition, we've just got more colleagues to join who are very much an experts in MEV and EVM semantics, all the trace calls, all the internal designs for EVMs, and a couple other folks. So one proud achievement for Fastland is that they have stopped over $30 million in attack, I think 40 last year, and they have returned the capital. Also, I think a couple of days ago, we also hacked time.fun. We returned all the money. The news is not out there, but we had the signer bypass, sort of a privilege escalation type of vulnerability identified on their site. So we took all the contract money away, but we returned it. You might know one of my colleagues called Chao Fan, who joined as part of the acquisition. He was leading the Libra investigation online. So he put in some money, and then unfortunately he got rug pulled as well. So he went deep into the basically on-chain data and see who was the perpetrators, and ultimately identified a couple of them. If you see Twitter, you'll be able to find his name. So because Layer is a traded token on Binance, Upbit, and all these other trading avenues, my compliance team want me to pull up these slides. Nothing I'm saying here is a statement. It should be construed as financial advice. So these are purely technical talks. It's not related to the token that's being traded at all. So there's no recommendation to buy, sell, hold, or even give away your token as a result of my presentation. So just want to also give you guys a background of where Solayer started. We actually started as a restaking protocol, but we engineered our restaking protocol not exactly as what EigenLayer did, which is a shared security. Now, the problem with that is that there's no organic yield yet, right? So shared security is more or less a borrow and lending model, where you want to have the demand for borrowing the stake to secure a particular site, exogenous ecosystem, but we don't really see that demand come up just quite yet. So we engineer things in a different way. We have a very much modified validator that's able to have a much higher yield. And then because of Solana's characteristics, we're allowing and helping other people to issue LSTs with shared liquidity pool. So if you hold SO, it can be transformed to SonicSO, which also has hundreds of millions of dollars in TVL, or BitGet, which is the exchange BitGet. So, and if you are trying to swap SO into SO, you can leverage the liquidity pool of SonicSO and BGSO. So think about transaction routing for swaps, but for this particular token, you're able to transform it into other representation of the same token, with a different branding, of course, and leverage different liquidity pools, because they're effectively the same token. So that's what we do. And then we do a lot of yield optimizations because of MEV and the better validator design. So there is also another service that we pushed out. It's called Solana Transaction Acceleration Service. What that means is that you're able to send the transaction to us and we'll make it included on chain much faster. So one of the problems with Solana is that your transaction don't get included. It will just get dropped. It will not get included by the validators because they don't even get a chance to see it. And that's because of network spamming, right? If you think about you being the leader, constructing transactions, constructing the blocks, and a lot of people are trying to send you messages, how are you able to find out who's the legitimate sender that's able to give you the real transaction stream? It's really hard. So the way you go around that is by saying, I only look at my peers who have stake, and I'll just maintain connection with peers who have stake. And because we have a lot of stake on the validators, so therefore we have a dedicated connection with whoever the current leader is with a high probability, and we'll just use that particular connection to route your transaction through to the validators. And so that's a side benefit of what we're doing. But we're making it free at acc.solayer.org if you want to check it out. It's what a lot of developers are using today. So because of our validator optimizations, our native SOL yield is much higher. You reached 19.8% during the Trump trade. So it's like really very high. And these are given out in native SOL. These are not airdrop wrapped marketing terms. These are just native SOL given out to you if you stake and hold as SOL or any of the other SOL that I mentioned. So the next chapter for Solayer is really building this, hardware-backed and infinitely scalable chain. And at the very starting point, we want to target a minimum of 1 million TPS. Now, the great news is that if you just want to share a bit of progress, if you go to explorer.solayer.org, you'll see an instance running at 500,000 TPS already, and that's live. If you're somehow able to get RPC endpoint, you can even send transaction to it. So that's just a preview of what's to come. Why do we start this, right? So we started this because during the Trump trade, and basically while we're building on Solana, we noticed a lot of congestion issues. EVM, SVM congestion issues don't manifest itself in the form of high fees, as does Ethereum or other EVM chains, where you pay like $60, right, to make a transaction. It manifests itself as dropped transaction. So when you try to make a trade, you won't go through. Like your transaction just gets dropped, pending for 60 seconds, and then expired. And that's the sort of when there's a congestion, that's how you feel as the end user. So we very much want to be able to increase that throughput, given that we feel there's a lot more demand for SVM coming up. Especially for token trading and various other needs. And the reason is very simple, right? It's because SVM has a much better user semantics. I don't know why the slides are kind of have the words shifted from where they're supposed to be. But on EVM, if you're trying to swap a token, you would have to approve the token first with a particular website contract, and you wait for 6 seconds on average because the block time is 12 seconds, right? And then you wait another 6 seconds to actually perform the swap. So you are performing, you're just trying to do one swap, but you have to wait for 2 transactions to confirm, and that's 4 2 mouth clicks as well. Just think about that. Whereas on SVM, it's not the same. You connect your wallet. If you want to trade or if you want to do anything like lending, borrowing, it's just 1 click. So that's the user experience difference, and it's very significant when it comes to the end user adoption. As you guys can see, probably where the meme coin trading volume is happening. It's not just a game of capital, because Ethereum, frankly, had more capital to begin with, right? Like all the USDCs are actually flowing from Ethereum to Solana. It's really because of the UI and the UX. You can theoretically start something with the liquidity pools on Ethereum, but people have tried, but they have not really been very successful. People still like the trading experience offered by SVM and Solana in particular, and therefore that's how we see SVM being this end user superior experience, being able to attract a lot more users to come over. Back to what we're building, just to put things into context, 1 million transaction per second is 100 times of what Monet is advertising. And the highest that Solana has ever recorded on public mainnet is only 7,000 transactions per second. The highest for Ethereum is 62. just to put things into perspective, right? And now, how do we construct such a high-performance blockchain? Let's first understand what 1 million transaction per second means. Assuming an average payload size of 1 kilobyte per transaction, you multiply it with 1 million transactions per second, that's 1 gigabytes per second, which is 10 gigabits if you convert it into bits, which is the networking unit that people use, is 10 gigabits per second. And this is just receiving, not even broadcast, like peer-to-peer broadcast. If you're connected with 10 peers, we're looking at 100 gigabits per second, just 10 peers, right? So you have to redesign the network topology a little bit. And because of this, we have to use a mega leader with a network of, we have to use a different network topology. And data center equipment is a must, just because there's no other way that you're able to push that high of a throughput through your network. And now, how do we maintain decentralization if there is this data center piece of equipment that's being used? So the idea is that we wouldn't let the network build the blocks. So there's a mega leader, but there's also a decentralized group of verifiers that's verifying all the transactions that the mega leader is sort of sending out. So that's the idea. And they still vote on the transaction states. It's just that they don't get to build the block. Now, there's another way, which is called asynchronous execution. The difference with that is that there's a technical difference. Why this is able to achieve a higher TPS is because ordering itself determines the TPS. Because as you are validating the transaction, there are concurrency and parallelism sort of guarantees depending on which order the transaction is being, depending on how transactions are being ordered. So if you order the transaction in a nice way, you're able to have much higher throughput than if you're just ordering the transaction, if somebody pre-ordered the transaction without considering throughput for you. So the ordering actually happens at the end of the validating stage. But it's a minor technical difference. So I mentioned about a decentralized group of verifiers, right? So how are they able to catch up to the chain state? Because we're running at 1 million transactions per second. The way to do it is because, yes, validating is very heavy, compute heavy. You also have to pull the I/O from your disk, right? And a bunch of these other operations, and we also have a hardware equipment we're using in order to achieve that high speed. But if you just apply the state, if you just trust the effect of the transaction that we also published, along with the original transaction, if you just trust that, you'll be able to catch up with the cluster state at a much higher rate. That's about 4 to 5 million transactions per second. If you just apply the state, like you don't validate, right? You just apply it, so you're able to follow along. Now, the way to do it is that they still need to verify the state, but not for the full state. So if you think about a transaction stream going because the leader is outputting a very fast stream, as the decentralized group of verifiers, their job is to validate part of the chain transition. They don't validate every single transition. For the part of the chain that they don't validate, they can just apply the effect, because we know that applying the effect of the transaction is very fast. So that's the trick over there. And we spoke about the execution stage acceleration by applying the effect. I also spoke about the network topology optimization, network topology redesign that we have to have in order for this chain to run at a super fast state. Now I also want to talk about seek, verify, and deduplication and scheduling. Seek, verify, and deduplication, which are separate stages that you can sort of, as a microservice architecture, you can sort of pipeline. Because you can pipeline it, you can actually have a dedicated cluster to do it. So we have a pre-execution stage that does two things. For every transaction that comes in, and these are parallelized, just add more machines if you want to. They do two things. One is scrubbing. So we do signature verification. Have you actually signed, or have all the signers that are supposed to sign the transaction, right? And these can happen at the edge with a lot of concurrency because they're just ED255.9 transactions. And semantics check of the transaction payload. And then the execution stage where we produce this transaction effect for our own validator applications to accelerate it. So that's sort of the things that we're doing. Just one more thing. So far, all the blockchain nodes are one single binary running on a single machine. And that's also a bottleneck, just because there's so much amount of I/O and storage you can scale. So for Solayer's InfiniSVM, it's actually a multi-executor model. We have multiple, multiple machines running together. That's a coherent state. And you're able to add more machines to add capacity, especially when it comes to I/O and basically I/O bandwidth. And they're all connected by some fancy equipment, which is really necessary in this case. It's called InfiniBand in AI training. So we're very familiar with that. We're just applying that to make sure that all the cluster nodes can, within the leader, can communicate at very high speed to make sure there's no latency for execution. So that's it. Yep.
Yeah, and with